Okay, so hi everyone, Senan on this side, and in this video we are going to see how to find the best time to buy and sell stock. This is the part 1, like there are multiple variations of this problem. Okay, so you are given an array of prices where prices of I is the price of given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Now return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. Okay. So what you would be given is a list of elements or the stock prices, and what this would be like: if you buy stock on day 1, you would get it would cost you 7. If you buy it on day 2, it would cost you 1. Same for the day 3, it would cost you 5. On day 4, 3, day 5, 6, and day 7. So day 1, 2, 3, 4, 5. On day 5, it would cost you 6. On day 6, it would cost you 4. But at the same time, you need to maximize profit. So if you buy at, let's say, buy on day 1, you need to sell it someday, right? Because if you don't sell it, you would anyways be on a loss, right? So if you buy on day 1 and then you sell on a later day, so if you buy with 7 and sell it at 5, you have a profit of -2. But if you bought it at day 2 and sold it at, let's say, day 6, you would have a profit of 5. And that is the maximum profit you can get out of this one. For anyone who is thinking, if you buy on day 2 and sell it on day 1, that could not be the case. You cannot sell something which you do not own. At least I think so that is the case. At least in this question, right? So, okay, so the brute force approach is what? You find all possible cases and you return the max. First, I'll do the brute force approach and then we'll see a more optimized solution, right? So for the brute force, I need to have int I is equal to, or int n is equal to prices dot size, and I can just have two iterators: I is equal to 0, I less than n, I plus plus, and for int j is equal to 0, j less than n, and j plus plus. Anyways, since you cannot, let's say I is the time, the day you buy, and j is the time you sell. So j cannot start from 0 because j should start from I plus 1. Why is this the case? Because the reason is, if you consider I, so you buy and sell on the same day, that means you have a profit of 0. Therefore, it's better you don't buy it at all, right? So why go to the problem of buying and selling? Okay, so if that is the case, what I do is, say, let's declare int, let's say, maximum price is equal to 0 and maximum is equal to max of maximum and, or what, nums of I minus nums of j. Find and in the end return maximum. I think that should do the job. Let's just see if this is working correctly, or not nums but prices. So on LeetCode, they generally give the array as nums, so it's my habit. Okay, where did I go wrong? Okay, so this is, I think, the opposite, j minus I. So the day you sell is the profit that you gained, minus the day you bought it is the cost that took you. So yep, this is working, and if I submit, I would probably get a time limit exceeded, right? Because we get using a big O of n square or order of n square time complexity. And yeah, time limit exceeded. So can we improve this? And we can actually improve this, and that would be a linear time solution, right? So int, let's say current max is equal to 0. And what I would do is, okay, what is the current maximum? Rather than doing this, we need to find like what is the minimum price. Let's say while traversing to this list towards the right, if I find the minimum price and if I sell on any of these days, definitely I would ensure that I buy it on this day too. Because if you use 3 as a buying date for 4 as the selling date, you would have a profit of 1. But rather than choosing 3, I would always choose 1, because if I buy it on day 2, sell it on day 6, I would have a profit of 3, right? So just while traversing through the list, we need to keep track of the current minimum element. So current, not max but current min, and let's say prices of 0, because either the first what you would do is buy it on the very first day or a later day in the later part of the day. And current maximum is 0, so rather than going from I equal to 0, I can start directly from I equal to 1, because if I buy and sell on the same day, the profit would be 0. And let's say rather than maximum, I use the word profit and do this as profit. Now what I do is, I see there are two cases. If my prices of I is greater than, or let's say if prices of I is less than what? My current minimum. If that is the case, what I would do is I would update this current minimum to prices of I. Otherwise, if that is not the case, I can actually calculate my profit. So profit till now is what? Max of whatever the profit I was able to achieve, or prices of I minus current min, and this would do the job. Let's just give it a go, and this is running well. Okay, so the basic idea is, while you're traversing the array at, let's say you have traversed till 5, you are just finding the profit, the max profit that you could get till that point, not what you would get totally. But if you just had the array 715, what would be the max profit you could gain? So when we had only a single element, the max profit would be 0. That is what we initialized 0 for. And the current minimum would also be 7, because we have only seen the number 7. Now if you move ahead, we find a new minimum, right? So if we find a new minimum, we cannot have a profit. We would definitely have a loss if I sell on that day, if I found a number which is the current minimum in the array. So in that case, I would just update my current minimum, because in no way I would be actually able to find the profit. Even if you remove this else, this would still work. But we are not trying to do that. So else, so that we don't actually have to do this every time we have a minimum, let's say, if the array is in decreasing order. So okay, yeah, I think that is the video. The space complexity is big O of 1, or constant space. Time complexity is big O of n, or order of n, which is linear time complexity, and that's the video, right? It's obviously it's an easy question. I don't think you would have any problem understanding it by yourself as well. Yeah, that was the video. Hope you guys enjoyed this. If yes, be sure to share it with someone who would find this useful. And yep, bye.